What are the best practices for caching? Caching is a crucial technique for enhancing the performance, scalability, and user experience of applications by temporarily storing copies of data so that future requests for that data can be served faster. Let's talk about some best practices for implementing caching effectively. First, we want to talk about, let me delete all of that. We want to talk about choose the appropriate cache location. We have mainly three locations. We have the client side caching, server side caching, and distributed caching. Let's start with the client side caching. Use browser caching to store static resources like CSS files, JavaScript, and images. This reduces the load on the server and speed up page loading times for repeat visits. We have the server side caching. Implement caching on the server for frequently accessed data, such as database query results or API responses. This can significantly reduce database load and improve response times. Number three, distributed caching. For distributed applications, especially in the microservices architecture, use distributed cache systems like Redis or Memcache to share state information across services and instances. This is the first thing that we want to talk about. Let's put this also in numbers. No, I don't want like that. Uh-huh. I, yeah, I guess this is better. Number two, we want to talk about defining the cache expiration policy. Here, here we have two things we want to talk about. First, which is the time to live with TTL, time to live. You should set a TTL for each cache entry to specify how long data should be stored before it becomes stale. The appropriate time to live depends on how frequently the data changes and the acceptable staleness for the application. Number two, we have a cache invalidation. Implement a mechanism to invalidate cached data when the underlying data changes. This ensures that users do not receive outdated information. Number three, use consistent hashing for distribution. For distributed cache systems, use consistent hashing to distribute data across multiple cache nodes. This helps in evenly distributing the load and minimizes cache misses during scaling operations or when nodes are added or removed. Number four, cache only the necessary data. Avoid caching large and infrequently accessed data. Analyze access patterns and cache only those items that are frequently accessed and relatively lightweight. Consider caching data that is expensive to compute or retrieve, such as complex query results or aggregated data. Number five, implement graceful degradation. Design the application to handle cache failures gracefully. Ensure that the application can still serve data from the primary data store, even if the cache is unavailable. Use fallback mechanisms such as loading data directly from the database if the cache misses occur. Number six, secure cached data. Ensure that that sensitive data stored in the cache is encrypted or anonymized, especially if it includes personal user information. Implement access controls for distributed caches to prevent unauthorized data access. Number seven, use conditional gets for web resources. Implement HTTP headers like etag and last modified for web resource. This allows the client to make conditional GET requests, asking the server to send the resource only if it has changed since the last request, thus saving bandwidth and reducing load. Number eight, monitor and optimize cache performance. Regularly monitor cache hit rates and adjust cache sizes and policies as needed. High cache miss rates might indicate that the cache size is too small or the expiration policy is too aggressive. Use monitoring tools to track the effectiveness of your caching strategy and make data driven decisions to optimize performance. Nine, which is the last, leverage content delivery networks. For global applications, use use CDNs to cache static content closer to users. This reduces latency and improves the speed of context delivery across geographically dispersed users. So, implementing these best practices will help in designing a robust caching strategy that improves application performance and scalability while maintaining data integrity and security. So that's it for today's video, and see you in the future.